Let's examine 2 points, and have point A, and it could be right here, and point B, and we'll put it a little bit higher. And we're going to find out everything we can about these points in terms of distance and that by determining an axis system. So I'm just going to put in with these points an axis. I'll change color to a white so we can see that. So I'm going to come down and go across, and this is the x-axis, the x-coordinates, and it's positive to the right. This is the y, and it's positive as it rises. So we can see, given the points from A to B, that you will be rising, and we're going to connect them with a line, and we're going to try and find out where these points might be. So to do that, we have to put a scale on it, and to make the scale we need to put points. So we'll say that scale is very important, and basically we want to make sure that they end up being the same. So let's just go ahead and put this point right here as our first one, and then we'll try to make this scale the same. So 1, 2, oh, I wasn't the same, was I? 3. And down we're going to look like 2, huh? And I'm trying to do a good scale, but I'm a little awkward with this. Alright, so now we have our x and y coordinates from that plane, and let's identify them. So A looks like it's the x coordinate is -2, and the y coordinate is also -2. And B has an x of 3 and a y coordinate of 1. And we're going from A to B. So what does that do for us in our understanding of where a point on this line might eventually be? So here's a quick look at what we want to learn. First we'll have our points right here, but the first thing we want to know out of that is something called the midpoint. And the midpoint is simply x1 plus, excuse me, I'm having a little bit of trouble with this pen, x2 sub 2, right? X sub 1 over 2, and y1, in other words, the values of x and the values of y, sub 2 over 2. So the values are added together and divided by 2, and that's certainly going to be the midpoint because it's the average. Then we want to know our slope, which is going to be the difference of y, which we call the rise, over the difference of an x, which we call the run. And then with that information, the distance between point A and B can be established as the delta y and delta x squared square root. So distance d equals the square root of basically the slope, right? Delta x squared plus the change in y squared. So the rise squared and the run squared and the rise squared. And then we're going to want to know that y equals mx plus b to find out what our actual run is in terms of finding our eventual y-intercept, which appears to be -1/2 or something around that. So with that, we're going to try and find the parallel and the perpendicular slopes. Now, the parallel slope is simply the same. That's called M1. And the perpendicular slope is minus 1 over M1. So our first point will be on the left A, and on the right B will be our second point. It's optional because addition is commutative. So we have adding minus 2, 3, minus 2, and 3, and dividing by 2. And then we have our minus 2 and 1. And being add 1 and divided by 2. So we see that our midpoint is minus 1/2, and as it turns out, minus 1/2. We should write that in our notation, which is difficult with this pen, but bear with me and I'll hopefully get it. So now our slope then is our second point. It would be 1 for y, and we're going to subtract minus 2, and of course we're going to put that in parens. And then the run will be 3, and we're going to subtract again that point minus 2. And we notice that our slope then is 1, and that turns out to a plus 2. So we have 1 plus 2, 3, and 1 and 3 plus 2, 5. Now, just to quickly verify that, we're going to look at the fact that the run to the right is from A is 1, 2, 3, 4, 5, and the rise from A is 1, 2, 3. So we see that just by counting, we did our subtraction right. Anyway, so now we want to do the distance, and so we're looking at the fact that the distance is going to be 9 plus 25, or square root of 34. So our slope then, and I'm going to choose point B, is going to be the fact that y is 1, when with our slope m of 3/5, and x is 3, and we're going to add b. So doing this the old-fashioned way, I'm going to use large parens, and take my LCM, which in this case is the prime number 5, and multiply times the entire inside. So I'm going to get 5 is going to give me, and of course the 5's make 1, so it's going to give me 9. 3 times 3 plus b, which shows me that b must be minus 4, but just going through it, minus 9 and minus 9. Aha! Shows me that it's plus 5b, and I did catch somebody on that, didn't I? And so then when I subtract my 9's, I find that minus 4 is equal to 5b, and when I divide my 5, I find that b is minus 4/5. So when I write my equation, I find that y is clearly 3/5 x, and from that my b, my y-intercept, is minus 4/5. And of course the m1 would be the same, 3/5, and the perpendicular would be minus 5, negative 5, or a drop of 5 for every run of 3. And that concludes a short summary of linear equations.